And again, this is probably review for those people that are in chemistry and were in ICP and had that chemistry portion and did well in it. Not everybody had that, so we got to go over it. Ionic bonds. What is an ionic bond? No, it is a bond between an atom with a positive charge and an atom with a negative charge. Remember, I don't write on where to work on my biceps, triceps, and deltoids. An atom with a positive charge and an atom with a negative charge. Another way to look at this is that it's a metal
abused my apple juice. I'm sorry.
plus a non-metal.
Technically, it's not domestic violence. Just 'cause I'm not.
Wow. Good like that. And you might be thinking to yourself, Self, how do I know the difference between a metal and a non-metal? Well, I'm not asking you to memorize the periodic table because it gives us all of this information. Most periodic tables that I see that you guys are using have a color coding. If you have a black and white periodic table, there's usually the periodic table, and I'm going to draw a really bad version of this. There is a stair-step line that kind of goes right here. I mean, it's probably a really bad version. It's not 100% accurate. But do you see that stair-step line that goes right here?
Yes.
Anything that is on this side or the right-hand side equals a non-metal. Anything that can be found on the left-hand side, which is 90% of the elements, equal metals. So if you ever see a chemical formula written with a metal plus a non-metal together, it's an ionic bond. How many people have gone through biology class? Everybody, right? Did they tell you the most important bond in biology is a covalent bond? Because it is. Because we are made with covalent bonds and sharing of bonds. The most important bond in all rocks, minerals, and earth science are ionic bonds. Rocks and minerals form through ionic bonding for the most part. There's covalence there too, but an ionic bond. The most common ionic bond is the element sodium plus the element chlorine. Not the most common, but it's the one that you have the most access to. Every single one of you in this room has consumed it today, guaranteed, in some way, shape, or form. Some people actually add extra to whatever they're eating.
Sugar.
Not sugar. Salt.
Pepper.
However, I like to talk about this because sodium has how many valence electrons? Got 1. Chlorine has how many? Got 7. Is sodium happy?
No.
Is sodium happy?
Yeah.
Sodium's not happy. Is chlorine happy?
Not yet.
No, not yet. See, sodium's not happy, neither is chlorine. So, sodium, I like to talk about this because sodium is a metal. It's a squishy metal. Like if you held it in your hand, you could squeeze it and it would like ooze through your fingertips. However, if you did that, it would have a chemical burn on your skin and you'd like pretty much have a bad hand for a while. It looks as shiny as the legs on the table. Hold up. It's as shiny as the legs on the table. But if you leave it out exposed to air for a long period of time, it'll catch on fire.
Wow.
If you take a little bit of sodium and drop it into water, it'll explode. Why is it so? Why will it burn your hand? Why will it catch on fire? Why will it explode in water? What about it makes it want to do that?
It's unstable.
It's unstable, good. But what makes it unstable? Valence electron. That one valence electron, does it want to stay?
Real in this class.
No.
It doesn't want to stay there at all. Will it stay if it's around a lot of other sodium ions? Yeah, because in all of those electrons just kind of share each other and they kind of swim around. That's how metals can conduct electricity, because all of those electrons are floating around, and you put an electrical charge on it, they fly to the other end, and they conduct that charge. Anyways, it's a metal that will kill you. Chemical burn. Chlorine. Does anybody know what chlorine is in the natural state? It is a gas. Do you know what color that gas might be? It's kind of like a mustard yellow. It's kind of a mustard colored yellow, and it's like a gold yellow. Have you ever heard of mustard gas? Take a wild stab at what makes up mustard gas.
Chlorine.
Chlorine. What is mustard gas used for? It's used in World War I as a what? It's a chemical weapon. Because as soon as you inhale it, it starts eating away at your lungs. Fun times. When I lived in Phoenix, Arizona in like 2001, there was a truck that was hauling the chlorine gas, and it tipped over and the tanker exploded. And they evacuated every building in a 15-mile radius. Because after that they figured it was dispersed wide enough. But they didn't want anybody to inhale it if they were too close to where that crash was at.
Okay.
Not to my knowledge, because they got everybody out quickly, but then everybody else walking around the crash was wearing all their gas mask stuff, like the hazmat suits and stuff. It's nasty stuff. Saddam Hussein has been known to use it, or Saddam Hussein was known to use it on his own people, just cause. It is a killer, right? So think about it. Why do you use it in a pool?
Kills bacteria.
Because it does what to the bacteria? Kills, right? But it's so small, and it's in such a small quantity when it's in a pool, that it doesn't have an effect on you. However, people are starting to believe that over-chlorinating and being overexposed to it is starting to cause people to go loopy. But I don't know if there's any proof to that, but there are people who are believing that.
So how pure is like the chlorine? How much chlorine is actually in it? Is that 1 or 2 chlorine?
They'll tell you, but it's a real small amount of chlorine. Like when you get, because what it is, it's a salt, essentially.
So strong.
Right? It's a salt that is going to get broken apart in the water, and then it's enough chlorine that stays in the water that it'll kill the bacteria. Do you know exactly how much it is? Okay.
Yeah, but it hurts.
When you get too much chlorine in it.
I've gotten it before the bucket spilled.
Oh yeah. Were you doing liquid chlorine or were you doing tablet?
We had those, but we were doing liquid.
Yeah, don't do that. That's like bleach. You're basically putting bleach on your skin, kind of a thing.
What was I thinking of that was chlorine gas?
I'm not sure.
Like it's what I read.
It's like a mustard. I want to say it's almost like it's a mix between Michaela's shirt and then the Purdue Gold kind of a thing. It's a weird looking mustard grass. However, here's the deal.
It says yellowy green.
Yellow, like I mean, look, it's kind of a green. Look at the colors of their shirts. You put them together and you're kind of getting the mustard gas. So yeah, I could give you green. When you say green, I'm thinking like a deep green. So you take a metal that can kill you. You take a gas that can kill you.
Yeah.
What do you do to those two things?
You eat them.
Sodium. Is chlorine happy? No. What's going to make chlorine happy?
If it shares that
If it
electron.
gets one electron, what's going to make sodium happy?
If it,
Giving up that electron. What happens when they give one up and take it in? You get a positive charge and negative charge. They stick together.
McDonald's French fries.
And you get salt. By the way, your body actually needs salt for it to grow. So you take something that can kill you, and it makes something that your body actually needs for a lot of growth and development.
Makes sense.